Good afternoon and welcome to your Science Review with Mr. Blades. Today we're going to go over how to draw a free body diagram and how to write our summation equations. Alright, so when you're starting to do a forces problem, you're probably going to want to start off with a free body diagram. So let's go ahead and show how to do one of those now. Now when we start off doing a free body diagram, we're trying to simplify all the information into a way that's easy to understand and do the math for. So we're going to start off with either a box or a square. Now when we're drawing our forces onto our free body diagram, we're going to draw them all radiating out from our box or our square. We're not going to show them going in. We're going to draw them going out. The little arrowheads on the end of each one indicate that the forces are in fact vectors. So let's go ahead and add some names to these. Usually pointed down will be the force of gravity. Usually pointed up will be the normal force. Normal in this case referring to the direction of the force. Some force to the right, usually I'm just going to call it FP for a push or a pull. And resisting that motion will be our force K, which is short for friction. Okay? K usually referring to the kinetic friction. Next, we're going to show how to draw our summation equations. Our general equation in forces is sigma F equals ma. That sigma is a Greek letter meaning the sum of. In math, we use that to refer to the adding up of all the different things. Okay? M being the mass and A is the acceleration. So when we add up all of our forces up here, we're going to add them up just with regular addition. Fn plus Fg plus Fp plus Fk equals mass times our acceleration. All right, and that's pretty much how we do our summation equation. However, we can break it into x and y components. So let's go ahead and do our sum of forces in the x direction. Now, x refers to sideways, so in this case, the sum of forces in our x direction will only refer to Fp plus Fk equals our mass times whatever our acceleration is in the x direction. Also, if we were to do our sum of forces in the y direction, that would only refer to our normal force plus our gravity force equals mass times our acceleration in the y direction. Now, when we have an equation like this, we can then analyze individual components. So let's go ahead and look at our Fg. Fg is calculated similarly with a mass times an acceleration. We have our mass, because the mass doesn't change, let's go ahead and write that in there, times the acceleration due to gravity. Here on Earth, that is 9.8 meters per second squared, but we can calculate that and then plug it in to our equations. Also, we can usually calculate our kinetic friction force using our kinetic friction force equation, where F of K is equal to mu K times the normal force. All right? And then we can calculate all of that. This should be helpful in getting started with most of the equations and problems in this unit. So I hope this was helpful. See you in class. Hey guys, now that you've watched that, please leave any comments or questions you have down in the comments. Also, any suggestions for problems or topics you'd like me to cover on my channel. Just like last week, I will take the first 5 comments, pick my favorite, and that person will get a bump on a daily grade. So I'll see you in class.